W2.2 is about something called phase difference. Now there's a very close relationship between circles and cycles. They don't seem very similar at first, but they're both repeating motions. If something is rotating, it's going around in circles. If it's oscillating, it's going through cycles. So in a circle, we have 360 degrees to go around one complete rotation. So we're all familiar with that, I think. So if you only went round half a circle, that would be 180 degrees, and a quarter of a circle would be 90 degrees, and so on. So you could work out how many degrees according to what fraction of a circle you turn through. So with a wave, we've got repeating motion again, but instead of a complete circle, we think about a complete wave, a complete cycle. So we say that this has got 360 degrees in it as well. So in half the cycle, we have 180 degrees. In a quarter cycle, we've got 90, just the same as a circle. But that's not the only way to measure angles. There is another way, another important way that we use quite frequently in both maths and physics. So imagine you've got a circle and it has a radius r. So if you were to take the length equivalent to the radius and wrap it around the edge of the circle, like that, then it would make an angle with the original position of the radius. And it wouldn't matter how big the circle was, that angle in the middle, theta, would always be exactly the same size. So this is a very straightforward and logical way of defining a section of a circle, a particular angle. And when this is the case, we've got r for the radius and r for the arc, then that angle in the middle is defined as 1 radian. If you were to take the radius and wrap it a few more times around the circle, you'd find it would fit just over 6 times, which is 2 pi, and hence we know the equation for the circumference of a circle is 2 pi r. So there are 2 pi radians in a circle. That may seem a little bit odd because obviously 2 pi isn't a whole number, but it still makes the maths a lot easier in many circumstances. So here we have a cycle again. And this time a complete cycle, rather than calling it 360 degrees, we can call it 2 pi radians, one complete cycle. So half a cycle is pi radians, and so on. If you do a quarter of a cycle, it would be pi by 2, and so on. So 2 pi radians in a circle, and also 2 pi radians in a complete wave. So in this diagram, we have 2 waves, an initial black wave and then a red wave that starts a little bit later. So in the top diagram, you can see there's what's called a phase difference between them. So they're shifted in position. The red one's shifted sideways by that much. And you just then have to think about how much of a complete cycle that shift is. So in the top diagram, the red one has shifted by half a cycle. You could also say it's shifted by 180 degrees, which is also half a cycle. And you could also say it's shifted by pi radians, again, half a cycle. In the middle diagram, it's not shifted so much. It's only shifted by a quarter of a cycle. And we could also call that 90 degrees, or pi by 2 radians, pi over 2. In the third diagram, the red one is shifted by 3/4 of a cycle. So we could express that as 270 degrees or 3 pi by 2 radians. So the definition of phase difference is that the phase difference between 2 vibrating particles is the fraction of a cycle between them, measured in either degrees or radians. One cycle is 360 degrees, is also equal to 2 pi radians.